The atmosphere above our planet is shaped like a wine glass. The height of its leg is 100 kilometers. The glass itself, starting from a height of 200 kilometers, begins to expand rapidly. In this glass is the islands, flies or swims, and we live under a dome. It is formed by the base of the stem of this heavenly wine glass. The height of this dome is only 12 kilometers. There is one hole in the dome. Through a pipe running inside the leg, rockets penetrate into the wide part where the islands floats. Fantastic! I'd like to think so. But don't jump to conclusions. A couple of years ago, I took the equation of state of an ideal gas from my school curriculum and started counting. And I got a very strange result. Now we will also calculate everything together. Grab your calculators. Repeat after me, and you make sure that you will be surprised and see how things really are. And so, the astronauts stubbornly do not want to give us any photos and videos of our planet. So there's something to hide. Well, let it be. We'll do the math. At the same time, we will check both ourselves and the astronauts. First of all, we will note what initial data we can use for our calculations. In electronic encyclopedias, in articles with titles like Earth's Atmosphere, there is such a picture. It shows several graphs. On the left vertical axis is the height above the Earth's surface. On the right vertical axis the pressure as the height increases. The horizontal axis is the actual surface of the planet. But the most interesting line, a vertical zigzag curve, is a graph of temperature at different heights above the Earth's surface. In my book Metaphysics of the Earth's Climate, published in 2016, I first drew public attention to this zigzag and made estimates. Let me remind you that this book became a bestseller, and for it I was awarded the Mikhailo Lomonosov Medal. So we have a graph of the Earth's atmosphere. We will assume that the data presented on it is reliable. Let's think together. How can we get new information about the shape of the atmosphere and, through it, the Earth itself from these reliable official data? It turns out that everything is very simple. For calculations, we take the combined gas law. From this equation, the graph of the data on atmospheric pressure and temperature. Only the volume remains unknown. We don't need the volume itself. We need the shape of this volume. How do I find it? Very simple. We will break the entire Earth's atmosphere in height into layers 1 kilometer thick. This is a differential number, where 1 kilometer is the step of differentiation. It allows you to keep the height of the layer constant, and the volume of the layer will be reflected by the size of the radius of this layer. In other words, if the volume of the next layer is larger than the previous one, then the radius of the next layer will be larger than the radius of the previous one. That is, each layer will be a flat cylinder, a pancake, 1 kilometer high. But the radius of this layer or pancake is exactly the desired value, which we will look for. Why do we need it? That's why. Remember the children's pyramid, when a child puts rings of different diameters on one rod. So with a different combination of these rings, you can tile a different shape. So will we. First, we'll calculate the radii of the atmospheric layers, and then we'll see what shape this atmospheric pyramid will give us. So, the volume of the pancake layer is equal to the height of this layer multiplied by its area. Let's substitute this value in the expression of the gas law, from which we get the radius of the current atmospheric layer. Now let's note the important thing: we are looking for the shape of the atmosphere, not its exact geometric parameters. Therefore, we will collect all the constants in the formula into one new constant, and so that it does not interfere with us at all, we will assume that its value is equal to 1. This approach to operations with constants does not affect the definition of the form. The values collected in the constant only affect the scale of the physical picture. And as a result, we get a simple and clear formula for calculating the radius of the Earth's atmosphere layer based on the values of the temperature and pressure of the atmosphere at the corresponding altitude. Then we gain patience and can't. Note that the temperature on the graph is shown in Celsius units. Therefore, when converting its values to kelvins, we will add 273 degrees to the current temperature value from 0 Celsius to 0 Kelvin. Calculating, we get the following results. Using these points, we build a shape that reflects the shape of our Earth's atmosphere. It turns out that such a glass or wine glass, it consists of a very thin leg and a very wide bell that starts from a height of 200 kilometers. We will return to the discussion of the shape itself, but for now we will consider the resulting geometry in fragments. We have to look at the fragments because the size of the lower part of the atmosphere and the upper part are too disparate. And when you image the entire atmosphere, the structure of the leg is absolutely not visible. The sharp expansion begins at 200 kilometers above the Earth's surface. And then this expansion only increases. Zoom in. We see that it is not so sharp, but still the expansion begins from a height of 15 kilometers above the Earth's surface. Let's zoom in again. Up to a height of 15 kilometers, there is only a leg of the same heavenly wine glass. This leg monotonously expands to the top to a height of 15 kilometers, and then the expansion becomes sharp. And finally, up to a height of 6 kilometers, the atmosphere above the Earth has the form of an almost flat column, expanding upwards. We live in the inner part of this pillar, and its borders serve as impassable barriers that we cannot go beyond under any circumstances. If we want to go beyond this atmosphere, we can only move up this column. And there's a much wider area up there for all sorts of maneuvers. This is the shape of the Earth's atmosphere that we get from the data that official science distributes as well known. You can see for yourself. There's no way to pull this color over a sphere. It can only be located above the ground, which is either flat or has some other complex shape. Once again, the zone of our life activity is limited to the inner space of this celestial atmospheric wine glass. In fact, don't let this shape of the Earth's atmosphere frighten you. Physicists have long gone beyond the spherical representation. Only they don't realize it yet. Here, for example, is how visible space is graphically represented. We see the same mouthpiece, a wine glass. And here is an illustration of the development of the universe. We see again the same mouthpiece or wine glass. But the closest form of the Earth's atmosphere corresponds to an ordinary vortex. This in general is correct, because the working fluid in the atmosphere and in the vortex is the same air. We see the same trunk or leg near the surface of the Earth, and the same extension at the top. Only the vortex works along the system from the bottom up, that is, it lifts material objects from the surface of the Earth and throws them into the sky. The Earth's atmosphere works the opposite way. It presses material objects to the surface of the Earth. This is what we call atmospheric pressure. It is likely that the Earth's atmosphere revolves around some center. This rotation can be very slow, and we perceive only some movements of air masses as wind. There is another model of such a fiber atmosphere. These are numbers. We will not dwell on it in detail. Just know that you can look at the world this way. This model shows. If it is accepted as correct, then the Earth may well be spherical. This layered sky completely coincides with the shape of the wine glass we obtained. Unevenness and excessive expansion are compensated by different thickness of a particular layer of the atmosphere. In this model, a thick section of the atmosphere, the one where all layers have the maximum thickness, rotates around the central Earth. In the area where all the thick layers are located, it is day at this moment, and where all the thin layers are located, it is night. The thickness of the sky provides the difference in the light mode of day and night, and not the sun. The sun itself is a glare that is formed when focusing the light emitted by the sky. This is the figure of the sky we were given by the figures of calculations obtained from the official classical parameters of the Earth's atmosphere. Check.